On 5K7, we're going to say on Ethernet 111, the switch port mode is FEX fabric, and the FEX associate is 102. On the other side, likewise, we'll say on E110, the switch port mode is FEX fabric, and the FEX associate is 101. Now, it shouldn't take very long for them to boot because they're already running the code version that we want because they were already previously associated. So if we look at the show FEX, we should ultimately see that both of these are going to come online. Now, from a configuration point of view of the end ports, so the E10111, which is configured in port channel 3, what we're now going to do is to move the VPC number from the port channel we had configured previously here, down at the bottom. So we have the port channel configured here and here. We need to take this VPC number and we're going to move it upstream to the fabric ports. So in this case, the VPC is going to exist here and here. One of the VPCs is going to represent 2K1. One of the VPCs is going to represent 2K2. So we're essentially doing a channel on this interface and this interface to talk to extender 1. Then we have a channel on this interface and this interface that's used to talk to extender 2. And this is what's referred to as the fabric VPC. So the port channel goes down to the extender. Then finally, if the extender is configuring a port channel down to the end host, this is the combination of both at the same time, which is what we call the enhanced VPC or the eVPC. So if we look at the show run interface, actually before I do that, we need to remove the VPC command from the port channel 3. And if we show run on interface E110 and 11, we're going to say that these are two different channels. So we have channel group 100, or actually we'll say 101 to match the associate number. And on E111, the channel group is going to be 102. Then likewise, we'll say on port channel 101, this is VPC 101, and port channel 102 will be VPC 102. So in other words, we're forming the virtual port channel down to the fabric extender. Then the fabric extender is going to form its own channel down to the end host. Okay, there's a question here, is this the same as VPC Plus? No, it's not. Okay, VPC Plus is related to Fabric Path. We'll talk about that a little bit later today. This type of design is called Enhanced VPC or eVPC. So it's when we have the VPC going from the parent switches down to the extenders. So there's a VPC here and here, and then there's going to be another VPC that goes down to the end server here. Okay, on 5K7, the same thing on the other side. So let's show run interface E110 to 11. We'll say E110 is going to be channel group 101. E111 is channel group 102. Now again, these numbers are locally significant. They don't have to match, but from an operational point of view, it doesn't make sense not to match them. That will be VPC 101. Port channel 102 will be VPC 102. So essentially now what we're telling the parent switches is that they need to synchronize the control plane between the ports on the extender because both of them are managing it at the same time. So when we learn a MAC address, we would synchronize that across the VPC peer link. So they would know, regardless of where the packets come from the northbound end of the network, we're still able to reach the final destination on the server's port channel. So we should see here shortly that both of the extenders go online. So let's look at the show VPC. We see port channel 101 and 102. These are the ones that are going down to the extenders. And we should see ultimately once the ports boot up to the servers, to the end hosts, we see that these get individual VPC numbers that are auto-generated. Okay, so these two are online, and then the second one is coming online. There we go. Okay, so let's look at the final config for this. If we look at the show, let's just show run. And let me pull out the important points of this. So specifically, we have the two features, so feature LACP and feature VPC. Okay, that's going to be for the VPC. Then we have the feature for the fabric extenders. Okay, next we have the VPC domain, which is used again to synchronize the control plane between the two switches. Port channel 2 is our VPC peer link. That's specifically where we're synchronizing the control plane. Then we're going to have the FEX facing ports. So we have E110 and 11. Those are the FEX ports. And those respectively are configured as channels. So we have channel 101, 102. These are specifically where the virtual port channels exist. So what this is saying is that when you go down to Fabric Extender 101, make sure you check with the other switch to synchronize any of the information that actually physically comes in that port. So when it comes in with a VN tag from the extender, so the 2Ks on the other side, we basically remove the VN tag and then look at the Ethernet frame inside of it. The source MAC addresses that we learn, we need to then tell the other VPC member over the peer link specifically what that information is. So again, without the peer link running, we cannot synchronize the control plane and we cannot do any actual data forwarding. So if we now look at the show VPC, the final verification should show that we have port channel number 3, which is the one that goes to the final end host. If we look at the show port channel summary, it says E10111 is down. Let's look at the other side. Show port channel summary. This one says 10211 is down. So let's look at the config. Let's look at the show run interface E10111 and E10211. And then check this on the opposite side. What's the issue here? They're both controlling the same ports, right? So the first parent switch says I have control of port 10111 and 10211. If they're in a channel together, they should have 100% identical configs. But at the same time, the config needs to be identical on the other parent as well. And this is the potential logic problem that you run into from an operational point of view when you're running the enhanced VPC. Since it's two independent control planes, two independent management planes that are referencing the same physical ports, if the config here does not 100% match the config here, then there's going to be a problem in the data plane. So we would basically have to take whatever config we have on one port and replicate it on the other one. And when we show run interface E10111 and E10211, we would have to take this config and paste it on the other one as well. So now if we show port channel summary, we see now both of the members are in the channel, and now the channel can come up. So from an operational point of view, it's real easy to make a mistake here that you configure something on one switch and not the other, and then it's going to break the communication down to the servers. So as I mentioned, there is a specific feature that is used to address this. It's called switch profiles or config sync. But from an actual operational point of view, it is kind of hard to get it to stay synchronized 100% of the time. But if you do want more information on this, where you can find this from the documentation is if we go down from main documentation, we're going to go products to switches, data center. NICs is 5K, whatever our model is, like in this case 5548, under the documentation to the configuration guides. And this is going to be under system management. System management and then configuring switch profiles. Okay, if we look at their example, basically what this allows you to do is it says we're going to use the protocol Cisco Fabric Services in order to synchronize the configuration that we want to do. So first off, the switches become peers of each other over the management port. They run this CFS over IP protocol. And what we're saying here is that every time I make a config change, I'm going to tell the other switch which has that management address what particular changes that I'm making. Okay, once both of them agree on this synchronization, it should say, yes, the switches are synchronized right now. Then once we actually make a change, like in this case they're doing a QoS config, you enter whatever commands that you want, but the difference is that instead of being in global config, you're in config sync mode. So where you would normally say config T to get to global config, you say config sync to get to sync mode, and that's where you make all of the changes. Once the changes, you're happy with whatever you want to send to the other switch, then you say you want to commit the changes, and then this sends it over the management port to the other switch, and then they both make sure to apply the config at the same time to whatever the downstream interface is. Now, if you are to use this in a real design, the thing you need to be aware of is that if you are using config sync, you have to use it 100% of the time. So you're no longer allowed to go into global config and make separate changes. You have to make all of the changes from the synchronization mode. So this means that when you're doing your initial deployment, basically the only thing you do in global config is give the switch a host name, give it a management address, and turn the Cisco Fabric Services protocol on. Beyond that, pretty much everything else needs to be synchronized between the switches under the switch profiles. So if you have an existing design, it's very difficult to migrate to a switch profile, but if you use the switch profile from the initial setup to begin with, then you should be able to manage it that way. There's a question, how does ISSU work with config sync? The problem is ISSU doesn't really work with enhanced VPC to begin with. Because the reason you're using config sync is you have multiple parents that are controlling the same downstream ports. But when you go to upgrade one of the parent switches, it upgrades all of the FEXs downstream. So there's supposed to be a supported order for it, but I personally haven't seen it work. That it reboots the downstream switches, which knocks the servers off of the data plane. If they're only singly attached, so if the FEX design looks like this one here, then ISSU is fine. Because you configure it on one switch, they reboot and knock this extender off. Then once it comes back, the code upgrade happens on the other one and it knocks the other extender off.